This is your class lesson for section 2.5, part 3, and we will be practicing and making sure you understand the quadratic formula. The formula uses the coefficients A, B, and C of this quadratic equation, and it places them in this equation that gives you the solutions x. So these are the same solutions that you would get if you factored and found those solutions. These are the same solutions that you would get if you completed the square. Okay? And the equation is x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay? And this is a very, very important expression under the square root, and it's called the discriminant. And I know you've had your lesson on that already, your video lesson, but I just want to point that out. It's really important. So let's give this a try. We're going to solve this equation using the quadratic formula. And so we have x squared minus 4x equals negative 2. So we have to go ahead and set this equation equal to 0. So I added 2 to both sides. Now, what I like to do is I like to write A is 1, B is negative 4, and C is 2. It's really nice to get those written so that you can come over and use the quadratic formula. So x is equal to the opposite of b, which would be a positive 4. Be careful, don't be messy. The opposite of negative 4. Well, it's just a positive 4. So try to do some of that and not make your quadratic formula jumbled up. This has helped many students. The square root, and we're going to square b and write 16. We're not going to write negative 4 squared, okay? It just keeps it nice and pretty. Then what I want you to do is I want you to write minus 4 and then put some parentheses. And I want you to multiply a and c together and write it there. So a times c is 2. All over 2a. 2 times a is 2. So go ahead and write what you get. Okay? Let's take a moment to solve this. We have 4 plus or minus the square root of 16 minus 8 all over 2. And that's equal to 4 plus or minus the square root of 8 over 2. See if we can come over here a little bit. And we get x is equal to 4 over 2 plus or minus the square root of 8 over 2. And we get 2 plus or minus, and that square root of 8 is the square root of 4 multiplied by the square root of 2 all over 2. So we get 2 plus or minus 2 root 2 over 2. And isn't that nice? We get 2 plus or minus root 2. That's what x is equal to. It's very nice. Okay, how about this? We're going to have non-real complex solutions here. I want to point out something. Do you see that what is under that square root, that discriminant, that b squared minus 4ac is a positive number? If it's a positive number, then we have real solutions. So that is a good thing to recognize. Okay, now let's go ahead and look at number 2. Okay, so we have to bring everything over to the left-hand side. Let's subtract x from both sides. And now let's add 4 to both sides. Okay, so now we have a is 2, b is negative 1, and c is 4. So x is the opposite of b, which is a positive 1, plus or minus the square root of b squared, which is 1. B squared is 1, minus 4, and you'll open up those parentheses. What goes in those parentheses is a times c, and then all over 2a, which is 4. Okay? So now we have 1 plus or minus the square root of 1 minus 32 all over 4. 1 plus or minus the square root of a negative 31 all over 4, which is equal to 1 plus or minus I root 31 all over 4. You can leave your answer like that, or you might want to divide each one of those terms in the numerator by 4. Okay? Now, these are imaginary solutions. These are not real solutions. Let's go take a look at that discriminant and see if that was obvious. Look at this discriminant. Our discriminant is negative. And when our discriminant is negative, we get 2 non-real solutions, okay? So that is same thing. Here we had 2 real solutions in the previous example. Okay, let's solve a cubic equation. And this will lead us to a quadratic formula. A little bit advanced, but I think you'll be okay with that, okay? The first thing we want to do is write this as x cubed plus 2 cubed equals 0. And this is always nice because we make this shell because we expect it to look like this. We put our x and our 2, we square our x, we square our 2, and we multiply 2 and x together. Then we use our signs, same, opposite, always positive. So let's go ahead and use our zero factor property. It must be that x plus 2 is equal to 0, or x squared minus 2x plus 4 is equal to 0. Okay? So x is equal to negative 2, and now if you try to factor this, you can't factor that by hand. So yep, you guessed it. We will be using the quadratic formula on this other factor, which is a quadratic. A is 1, B is negative 2, and C is 4. X is equal to the opposite of B, plus or minus the square root of B squared minus 4. We're going to put A times C in there, all divided by 2A. So we have 2 plus or minus the square root of 4 minus 16 all over 2. We're getting there. 2 plus or minus the square root of negative 12 over 2. That's equal to 2 plus or minus I root 12 over 2. 2 plus or minus I root 4 multiplied by root 3 all over 2. 2 plus or minus 2I root 3. Put this 2 in the front. All divided by 2. Now if we divide each one of those terms in the numerator, we get 1 plus or minus I root 3. So we have 2 solutions here and another one here. So we actually have 3 solutions. I want to point something out. This discriminant is negative, so we expected 2 non-real solutions. Okay? Let's review this discriminant, okay? This discriminant is just b squared minus 4ac. It does not have the square root on it, okay? So if it is a positive number, you have two solutions. We're going to talk more about this perfect square and not a perfect square in a minute. And these are real. Solutions. And we're going to give you a little more detail in a minute. If you have a 0 for the discriminant, you only have one solution, and it is real. And if you have a negative discriminant, you have two solutions, but they are imaginary. They are non-real. So I'm just going to put imaginary, and you can also put non-real complex. Okay? Now let's fill in the blank above. Okay? If you have a positive discriminant and it happens to be a perfect square, what's a perfect square? A perfect square is 16. A perfect square is 49, and so forth. Your solutions will not only be real, but they will also be rational. Now, a rational number can be written as a fraction. You hear that word fraction? Rational. Okay? But if it's positive, but it's not a perfect square, such as 7 or 15, let's say, they are both real, but they are irrational numbers. Well, the good news here is that, of course, if you have 0 for your discriminant, you'll have one real rational solution. So we're not going to solve these. All we're going to do is we're going to look at these equations, and we are going to tell whether the solutions are rational, irrational, or non-real, and we're also going to tell them how many solutions there are. All from the discriminant. So this is already set equal to 0. A is 5, B is 2, and C is negative 4. B squared minus 4AC is equal to 4 minus 4 times negative 20. 4 plus 80, and that's 84. Now, 84 is not a perfect square, but it is positive. So we have it's positive, so we have two real solutions. And they are irrational. Okay, let's try this next one. A is 1, B is negative 10. Oops, I can go ahead and write ABC, but I think it's better to bring it over, just so you don't make a mistake. Minus 10x plus 25 is equal to 0. A is 1, B is negative 10, C is 25. B squared minus 4AC is 100 minus 4 times 25. 100 minus 100, and we get 0 for the discriminant. And if we have a discriminant equal to 0, we have one real solution, and it's rational. Let's try C. A is 2, B is negative 1, and C is 1. B squared minus 4AC is a positive 1 minus 4 times 2. 1 minus 8, that's a negative 7. That's a negative number. So we have two solutions, but they are imaginary. Two imaginary solutions. And if you want, you can say that they are non-real complex. It's a complex number that's not real. And that concludes this class lesson.